Hello everyone, welcome back to my channel. Happy New Year, and this video will be my first video of year 2024. So what am I supposed to talk today? Today I have prepared something interesting to those who would like to learn more about pinch analysis. If you remember last time, I did show you a method, a graphical method to do a pinch analysis. But today we're going to do another, I'm going to show you another method, which is called a problem table method in order for you to do pinch analysis of multiple hot and cold stream. Let's begin. Before that, let me give you a brief introduction about problem table method, but not really a brief introduction. It's more of like what's the reason, what are the motivation for us using problem table method as opposed to the traditional graphical approach method. Well, of course, when we're dealing with the graphical approach method, it is quite, we can see how the composite curve looks like graphically because, we can see it, as you can see from the figure on your right. But of course, it is quite difficult to prepare, especially when we are dealing with like maybe 10 or 20 hot and cold stream. That it's going to be a nightmare for us to prepare those hot and cold composite curve. Um, and another thing, when we deal with the manual drawing, things can be imprecise, especially when you want to locate the pinch temperature, you want to calculate heat recovery or hot and cold utility usage and stuff like that. And it can also be quite messy. This is true, by the way, especially when my students preparing their composite curve, especially during the exam or test, because they have limited time. So, the quality of their composite curve is not that great. So, because all of these issues, people have developed problem table method. Basically, it allow us to solve energy target uh, algebra energy target mathematically. Okay, I don't know. I got tongue twisted, but whatever. Okay, what is our problem? So I'm going to use the same tutorial problem method. I'm not going to go into details, but what we are trying to do is we would like to find what is our pinch temperature, utility requirement, both hot and cold, as well as our energy recovery. We will use the same delta T minimum of 10 degrees Celsius, but in your practice, let's say you want to do practice, you can use whatever number that you want, 5, 10, 7, whatever number that you want. But in my case, I'm just using 10 for consistency purposes because previous video I did use a delta T minimum of 10. Okay, what do we have here? We still have four stream, two hot stream and then two cold stream. We have their CP value here. Hot stream 1, CP of 3, temperature 170, need to be cooled down to 60. Hot stream number 2, H2, CP of 1.5, need to be cooled down from 150 to 30. And then cold stream number 1, having a CP of 2.0, need to be heated up from 25 to 135. And then lastly, cold stream number 2 or C2 need to be having a CP of 4.0, need to be heated up from 80 to 150. So how can we uh, get all of this required information using problem table method? So let's check it out. Okay, they have like several steps. Basically, it can be divided into three steps. The first step here is you need to shift the temperature. If you see on the slide right now, any cold stream need to be shifted by half of delta T minimum, while hot stream need to be shifted down by half of delta T minimum. Now that we have our delta T minimum of 10, so we have for hot H1 and H2, the value will be -5 here, as you can see, and -5 here. And for cold stream, it's going to be a +5 as well as +5 for cold stream number 2. Now, these are just their temperature. Uh, going in, initial temperature, and then their desired or their target temperature, if you will. And then this one is the shifted temperature of the initial temperature of the stream. And then the next column is basically, this is T2, by the way, it's a mistake. The next column is basically the shifted temperature of the target temperature of the stream. So it's quite easy. So how to calculate is basically 170 minus 5. For this one, 150 minus 5, you get 145, and then 165. Same goes with the T2. It's basically 60 minus 5, 55, 30 minus 5 is 25. And then you repeat for the cold stream, but for the cold stream, you just need to add 5 plus 5. So here, 25 plus 5 is 30, and then 80 plus 5 is 85. 135 plus 5 is 140, 150 plus 5, these are plus by the way, is equal to 155. The next step is basically to use to populate this table, and then calculate the remaining column with this equation. I know you cannot see, but I will explain what are the equation. But first, the first column here is the shifted temperature of all of it, all of the stream. So basically, when you see the T1s and then T2s, whatever numbers, just populate the table using the temperature, the shifted temperatures, and then arrange them according to the decreasing temperature value. So from higher temperature to a lower temperature. And then here's your stream population, basically for a stream number. I don't know what is the stream, by the way, but it's probably C2. Let's say, for example, this is C2 from 30 to 140 for the shifted temperature. And then cold stream number 1, I think, I could be wrong, by the way, but you need to check my earlier the slides, a few slides before. So the shifted temperature is between 85 to 155. Hot stream is from 145 to 25, and then from 165 to 55. So these are stream population. Just draw something like this. Just create something like this. The first column is the shifted temperature arranged according to the descending order of temperature for both hot and cold stream. And then you populate this level, I guess temperature level by the stream, cold stream and hot stream, all of it. Here is delta T, basically temperature difference, temperature interval, if you will, between this line and then this line. So how do I get 10? It's basically 165 minus 155 is 10. So temperature interval between here to here, you repeat the same thing from here to here, which is 155 minus 145. 145 to 140, the interval is 5. 140 to 85, the interval is 55. From 85 to 55, the interval is 30. From 55 to 30, the interval of 25. And then from 30 to 25, the interval of 5. So you basically, in step number 2, you need to complete this whole table. But the first thing first, calculate the first 3 column, which is shifted temperature, stream population, and calculate the temperature interval between each shifted temperature. Okay, what are the next column here? If you see, these are the term blue. I don't know whether you can see, but basically it is like this. It is the summation of the CP of the cold stream minus summation of the CP of the hot stream. This is the term blue with the font color blue. I don't know whether you can see this or not, but whatever, it's fine. So how do I get minus 3 here? It's quite simple. So between this interval, right, between 165 to 155, I do not have any cold stream, so it's 0 minus hot stream CP, which is I only have one stream, which is 3. So 0 minus 3 is negative 3, is negative 3. So it is a summation of the cold stream minus summation of the hot stream. If there are no hot stream or cold stream is going to be 0, as simple as that. Okay, maybe one more, I guess, maybe two more. So for the second interval, if you see, I have one cold stream and then one hot stream. So if you see the equation, it is a summation of cold stream minus summation of hot stream CP. So here I have one cold stream CP, which is 4.0 minus 3.0, which is the CP of the cold stream. So that's how you get 1.0. Let's find another one. Okay, maybe the third interval here is this is quite it's not complex, but this probably highlight the how the equation would function. Uh, so yeah, for the third what is it called here interval, I have one blue line, one cold stream, and then two hot stream. So how can I calculate the blue term here is, so it is a summation of CP of cold stream. I only have one cold stream, which is having a CP of 4.0. So 4.0 minus summation of two cold stream CP and two hot stream CP, which is 4.0 minus sum of 1.5 here, plus 3.0, then you will get negative 1.5, negative 0.5. And then maybe let's check out one more, I guess. This one will cover all of it. So between 140 and 85, okay, this interval, between 140 to 85, I have one cold stream and one cold stream also, and then one hot stream and then one hot stream. So two cold stream and then two hot stream. So how can I do calculation? Again, the same thing, summation of cold CP minus summation of hot CP. So you take a sum of this, 2 plus 4, so 2 plus 4 minus 1.5 plus 3.0, summation of hot stream, you will get 1.5. You do the same for the rest, and then you will get the values. Just follow the equation. Okay, what to do next? So if you see, we need to populate the next column, the second last column. So which is total heat, no heat enthalpy in kilowatt for each interval. So how do I calculate this? It's quite simple. It's basically this term, the blue term, multiplied by delta t interval. So 3 minus 3 multiplied by 10, minus 3 multiplied by 10 is minus 30. 1 multiplied by 10 is 10. Minus half multiplied by 5 is minus 2.5. 1.5 plus multiplied by 55 is 82.5. Minus 2, negative 2.5 multiplied by 30 is 70, minus 75. 0.5 multiplied by 25 is 12.5. And then the last one is negative 1.5 multiplied by 5 is negative 7.5. Okay, it's done. What do we need to do with this last column here? So the last column here is basically a designation whether the heat here is a surplus or deficit. So how can I identify those? So basically, any negative heat, any negative enthalpy in the second last column here will be considered as surplus. So negative 30 is surplus, negative 2.5 is also surplus, negative 75 is also a surplus, and then negative 7.5 is also a surplus. Now, don't ask me why they decide that way. I don't really care, but well, that's their designation. But does it really help in terms of like calculating what's the pinch hot utility and cold utility? Not really, because what I care is just the number here, not the designation. And then of course for the positive number, positive enthalpy, you're going to assign them as a deficit. Okay, now that you have done this table, the third and last step would be to cascade the heat flow from from low temperature to higher temperature, or from higher temperature to low temperature. So basically, you arrange the heat flow according to the interval. Simple as that. As you can see here, the first thing first, you have a hot utility. Okay, because at higher temperature, at the highest temperature, above it need to be supplied by hot utility, and at the lowest temperature need to be supplied by cold utility. All right. So basically, the highest one, the top one is hot utility. The bottom one is a cold utility. Now on the left, you just simply put the shifted temperature, the first column, if you remember, and then in here, between each interval, you have between from 165 to 155, you assign their heat, which is negative 30. So in here, it's zero. I will explain this one later, I guess. So between 155 to 145, you assign 10. So between 145 to 140, you assign negative 2.5. Between 140 to 85, you assign 82.5. And then between 85 to 55, you assign minus 75. Between 55 and 30, you assign negative 12.5. You assign 12.5, which is here. And then lastly, between 30 to 25, you will have enthalpy of negative 7.5. So you create something like this. You create a cascade essentially from higher temperature to lower temperature. Uh, but in my what is called in my title here, from low temperature to higher temperature. Maybe it's correct actually. I don't know. I'm not really good with grammar, but whatever. So on the left column is the shifted temperature. So on the right column here, at 165 is basically zero. On the second, at 155 is basically zero minus whatever heat here, which is negative 30, you get 30. And then from 155 to 145, so you get this number 30 minus uh, 10, which is a positive number, so you get 20. And then you repeat from 145 to 140, you pick the same number 20 minus whatever enthalpy here, which is negative 2.5, you will get 22.5, and then you do the same for the rest of the cascade. Okay, after that, after you have done all of those, you find what is the largest negative number. So as you can see, the largest negative number is minus 60. So you choose this one, minus 60, you remember? Try to remember this number, because what you need to do next is to make the cascade here feasible. You need to make every number positive. Um, so basically, you need to make all of the numbers greater than zero. So you add everything with the with 60. So 0 plus 60, because earlier you know that the smallest number is negative 60. So the rest you just plus 60 to make this term zero, because I don't want to have any zero number and any negative number. So you need to plus with the largest negative number. So the opposite of that, you need to plus with a positive number, which is 60. So you do the same for the rest. So 0 plus 60 is 60, 30 plus 60 is 90, 20 plus 60 is 80, 22.5 plus 60 is 82.5, minus 60 plus 60 is 0. So 15 plus 60 is 75, 2.5 plus 60 is 62.5, 10 plus 60 is 70. Now that we have done all those, if you see, at the temperature where the heat is zero, okay, um, you will have the shifted pinch temperature. Now, 85 here belongs to cold temperature, cold stream, by the way. So, because 85 here is basically 80 plus 5, so you get 85. So, hot pinch is 90 because delta T minimum of 10. As simple as that. So basically, the temperature, the shifted temperature where you will have zero heat flow will be your shifted pinch temperature. But the cold pinch is 80, the hot pinch is 90. And then you go above the very first heat flow here, this will be your hot utility. Okay, 60 kilowatt need to be provided by your hot utility. It can be hot oil, medium pressure steam, high pressure steam, or whatever, and then the heat flow at the bottom of the cascade will be supplied by coal utility, and then the amount is 70 kilowatt. Um, it can be cooling water, or any cooling refrigerant, or maybe just a cold air or whatever, So from here, um, s- from the problem table method, it does not involve any graphical approach. So, but you still get the same information. You can still solve the pinch of multiple stream, where you still got the pinch, hot and cold pinch, utility usage, the hot utility, your cold utility as well. That's pretty much how you solve a pinch of multiple stream using a problem table method. All right, everyone. That's pretty much it. I hope you like the videos. Again, any comment, please feel free to write it down in the comment section. I'll try to reply if I have new piece of information or if I'm able to entertain your question. So yeah, I will see you guys in my next video. Right? Bye bye and have a very nice day.